Okay, so I'm going to go through the solutions to the test that you had last week. Now, it was an open book test, so hopefully everything made sense to you, but I want to go through the solutions in detail anyway, and you'll have this video to refer to when you're studying. And also, if there was anything you didn't understand from your corrections, you'll be able to see it here. So if at the end of this there's something you still don't understand, you might let me know in a question on today's Google Classroom post. Okay, so the first question we had here, there are 4 squares labelled A, B, C, D, and part of each square is shaded in. Write the correct letter into each space to show which 2 squares have 3/4 of their area shaded, so 3 out of 4. Well, A has 4 sections and 3 of them are shaded, so this one definitely has 3/4. You can write it in straight away. B has 6 sections and 3 of them are shaded. So it has 3/6 or 1/2 of B is shaded. C has 16 squares and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12/16 of C is shaded, and when we simplify that, 4 goes into both, we get 3/4. So C is the second answer. We weren't asked about D, but we'll do it anyway. We've got 9 squares in total, and 7 of them are shaded. So that's how we worked out, and you might have done your working out down here. That's how you worked out which 2 squares had 3/4 of their area shaded. It was testing, did you understand equivalent fractions? Now, part B asked us to shade in 3/5 of this rectangle, which is broken into 10 small squares. So 3/5 is the same as 6/10. So any of the 6 squares here, 1, 2, 3, 4, 5, 6. And it doesn't matter which 6 you shade, so long as you shade in 6 of those squares. Okay, it can be in any order. Let's move on to the next question. And we're asked to count the number of tiles in the diagram above. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 tiles. Nice easy question, just having to count. How many of these tiles are now shaded? 1, 2, 3, 4. 4 shaded tiles. And they want us to express the number of shaded tiles as a percentage of the total. First, we'll write it as a fraction, and then we'll multiply by 100 to get a percentage. You can simplify that to 1/4 first and then do your multiplication. You get the same answer, 25%. And it doesn't matter which way you do it. You don't need to simplify it before you multiply by 100. I don't mind if you use your calculator to do that calculation, so long as we have the correct final answer. Okay, the next question. Michael buys 5 items in a shop. He estimates, so he's going to be doing some rounding, the total cost of his purchases by rounding each item to the nearest euro and then adding the estimates. So we must complete this to show his estimates here. €2.80 would round to 3, €1.79 would round to 2, 34 cents to the nearest euro would round down to 0, 1.23 would round to 1, and 79 cents would round to 1. And when we add these up, we get 5, 6, 7 euro. Now we're going to find the actual cost as well, and let's use the calculator to do that. So 2.80 plus 1.79 plus 34 cents. Let's write it as a decimal. 0.34 plus 1.23, 79 cents. Let's write that as a decimal as well. 0.79. And so his total spend was €6.95. That was a pretty good estimate. Do we have to put our euro symbol on each line? We don't have to. Okay, you can just put it at the top. If you put it on the last line, that's sufficient, but I don't mind if you fill it in, everyone. Find the difference between the actual cost and Michael's estimate. So the estimate minus the actual. You'll always do the bigger number take away the smaller number for this difference. So €7, take away €6.95. We can do that in our head. It is 5 cents. Now, the numbers in the table below here were rounded using different methods. So this was rounded to 852 and it was rounded to the nearest whole number. And they want us to describe what happened here. 0.0026 rounded to 0.003. This was rounded to 3 decimal places. 3 decimal places. This rounded to 1 decimal place, and we must actually do it, so we're going to be rounding up. 798.8 to 1 decimal place. This was rounded to 2 decimal places, and we have to come up with a number that this could have been. Now, it doesn't matter. We might have different answers here, so long as they would round to 12.34 when you round it to 2 decimal places. That's what we want. So, for example, 12.34189 or 12.337, etc. There's lots of different answers that could fit in here, and so long as it would round to 12.34, you'll get your full marks there. The next question, in the diagram below, what fraction of row A is shaded? So just this on its own. Now A, the row of A, has 4 boxes and 3 of them are shaded. In the same diagram, what fraction of column R? So column is going down, rows are going across. 1, 2, 3, 4, 5, 6, 7 in total, and 5/7 are shaded. Using the diagram or otherwise, calculate the result when your fractions in part 1 and part 2 are multiplied. So 3/4 multiplied by 5/7, and we can do top by top, 15, bottom by bottom, 28. 15 28s, and let's just show that we get the same answer as that in our calculator. 3/4 multiplied by 5/7 gives us 15 out of 28. So top by top, bottom by bottom. I can't tell whether you used a calculator or you did it in your head, and that's fine. It's a simple calculation, so it's fine if you used the calculator. There's no work that you could really show. Tim claims that the 2 fractions, just before I do part B, I just want to note, if you counted up all the boxes here, you would get a total of 28 boxes. And if I count up all the shaded ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's just showing that this diagram is another way to do our multiplication. We didn't learn a diagram like that, but it makes sense when we see it. Tim claims that the 2 fractions shown by shading strips A and B below are the same. Is Tim correct? Now, the answer is no, he's not correct. Certainly the shaded area comes to the same place, but the total distance here is not the same. So B is shorter than A, and that's one explanation, but also A has 3 out of 5 parts shaded, and B has 2 out of 3 parts shaded, and 3/5 is not the same as 2/3. They're not the same. They don't have the same value. Okay? And now let's move on to the next one. Finally, Sheila orders 2 pizzas to divide evenly between herself and 5 friends. So we have a total of 6 people. What fraction of the pizza will each person get? We're going to have 2 divided by 6 people. And as I have said to you from the very beginning this year, divide and fraction, they're the same thing. So 2/6, which simplifies to 1/3 in its simplest form. That's really important. And even if the question doesn't say in its simplest form, we always simplify fractions. One of the friends gets a text and leaves before the pizza is delivered. What fraction will each person now get if the pizzas are divided evenly between those remaining? So now I have 5 people, and I've got 2 pizzas divided by 5 people, and that is 2/5, which doesn't simplify any further. Find out how much extra pizza, so this was a bit challenging, each person got. So we're looking for the difference between the fractions. And I did want to see some working out here, okay? You could use your calculator to help you. Which one is bigger? Well, once somebody has gone, the 2/5 must be bigger. These people are getting more pizza than these people were. So it will be 2/5 minus 1/3. We would write our common denominator of 15. Then we would have 2 times 5 into the 15 goes 3 times, minus 1 times 3 into 15 goes 5 times. And that is 6 minus 5 over 15, which is 1/15. So look, if you just did that whole calculation in your calculator, 2/5 minus 1/3, I will give you most of the marks, but because I do want to see this work, I won't give you quite full marks unless I see that work, okay? Now, that was it. Hopefully that was a fairly straightforward test and you're feeling confident with fractions, decimals and percentages because we need to use them quite a bit in probability. So all I want you to do today is go through the corrections of your test and let me know if there's anything that you don't understand. Okay, thank you very much.